The transition from Optimus 2.5 to Gen 3 is particularly important because Tesla itself has described Gen 3 as our first design meant for mass production. The company said Gen 3 would include major upgrades from version 2.5, including its latest hand design. Tesla also stated that preparations for the first production line were already underway, with supply chain readiness being developed alongside the factory, production planned to begin before the end of 2026 and eventual planned capacity reaching 1 million robots per year. That is a completely different proposition from building a few hundred demonstration robots. A production target of 1 million units per year means Tesla is already thinking about Optimus as a product that has to be manufactured at automotive scale. For perspective, Tesla produced 1.65 million vehicles in 2025. A single Optimus factory designed for 1 million robots annually would therefore have a theoretical output approaching the scale of Tesla's entire annual vehicle production today. And Tesla did not stop there. In its Q1 2026 update, Tesla said preparations for its first large-scale Optimus factory would begin shortly. The first-generation production line, designed for 1 million robots per year, is planned to replace the Model S and Model X production lines in Fremont. At the same time, Tesla said it was preparing Gigafactory Texas for a second-generation Optimus production line designed for long-term annual capacity of 10 million robots. That 10 million figure changes the story dramatically. If Tesla actually reached 10 million robots per year, it would be producing more humanoid robots in a single year than the entire existing humanoid robotics market has produced over many years. And this is exactly why Optimus should not be viewed simply as another Tesla product. Tesla is attempting to create the manufacturing infrastructure for a completely new category of machine. The company has also established a formal milestone around the scale of the business. Tesla's 2025 proxy materials define 1 million bots delivered as the delivery of at least 1 million AI-powered mobile robots manufactured by or for Tesla, including Optimus and future successors or enhancements. That detail is particularly revealing because Tesla is not limiting the definition to one specific Optimus generation. The company is effectively defining the bot as a continuing product platform. Gen 3 can evolve into Gen 4, Gen 5, and future versions without abandoning the underlying business model. This fits with Elon Musk's much bigger prediction about Optimus. Musk has said, "My prediction is that a majority of Tesla's long-term value will be Optimus." That is an extraordinary statement because it suggests Musk does not see Optimus as a side business alongside Tesla's vehicles. He sees humanoid robotics as potentially one of the company's most important sources of long-term value. And there is a reason Tesla believes it can pursue that ambition. Musk has explained, and everything we've developed for our cars, the batteries, power electronics, the advanced motors, gearboxes, the software, the AI inference computer, it all actually applies to a humanoid robot. Tesla itself has used essentially the same argument when presenting Optimus as part of its broader AI and robotics strategy. That means Tesla is potentially transferring years of accumulated automotive engineering into robotics. The batteries developed for electric vehicles can provide energy storage. Advanced motors can provide movement. Power electronics can control those motors. Gearboxes can transmit mechanical force. AI computers can process perception and control. And Tesla's experience with high-volume manufacturing can be applied to the robot itself. But there is another piece of evidence that makes the strategy even more interesting. At Tesla's CVPR 2026 event, the company described its robotics research as involving foundation models for robotics, with large-scale multimodal models controlling robots in an end-to-end pixels-to-actuation system. Tesla also said its work involves architecture, data, training, evaluation, safety, and reliable real-world deployment. That suggests the real Optimus strategy is not simply about building a better mechanical body. Tesla is trying to connect the entire stack: robot hardware, AI models, training data, simulation, physical world feedback, and mass production. And this is where the progression from Gen 3 to Gen 4 and Gen 5 becomes important. Each generation can potentially improve the physical design while the AI system continues learning from an expanding fleet. The more robots Tesla deploys, the more real-world situations can potentially be captured. The more data Tesla obtains, the more the next generation can be trained and refined. So when Tesla talks about 1 million robots and then a production line designed for 10 million robots per year, these numbers should not be viewed as isolated manufacturing targets. They represent a much larger ambition. Tesla is trying to turn Optimus into a continuously evolving product platform where Gen 3 establishes mass production, Later generations improve the hardware and intelligence, and increasingly large factories make those improvements available to millions of machines. That is why Gen 3 could become much more important than simply the next version of Optimus. Gen 3 could be the point where Tesla stops proving that it can build a humanoid robot and starts proving that it can manufacture an entire population of them. Optimus Gen 3 and real-time 3D mapping. How will it understand a house? Consider Gen 3 entering a house it has never seen before. There are no factory lanes, no fixed robot routes, and no guarantee that objects will remain in the same place. A chair can be moved into the middle of a room, a child's toy can be left on the floor, a dog can be sleeping in the hallway, and a person can suddenly walk directly in front of the robot. Gen 3 therefore cannot depend on a static map. It needs to continuously construct and update an internal representation of the environment while performing its task. Tesla already has an important technological foundation for this. Its vision networks analyze camera images for semantic segmentation, object detection, and monocular depth estimation, while its bird's-eye view networks process video from all cameras to generate information about road layouts, static infrastructure, and 3D objects from a top-down perspective. Tesla says a full build of its self-driving neural networks involves 48 neural networks, requires approximately 70,000 GPU hours to train, and produces around 1,000 distinct tensors or predictions at each time step. For Gen 3, the significance is not that Tesla can simply copy FSD into a humanoid robot. The important point is that Tesla has already spent years developing systems designed to convert visual information into a high-fidelity representation of the physical world. Tesla explicitly says its autonomy algorithms create a representation of the world and plan trajectories within that space, while its neural networks learn from scenarios gathered from a fleet of millions of vehicles in real time. Tesla has also explicitly confirmed that it is applying its self-driving AI experience to Optimus. In its filings, the company says it is applying its AI learnings from self-driving technology to bots such as Optimus, while describing Optimus as a general-purpose autonomous humanoid robot. This is important because it suggests Gen 3 is not being developed in isolation from Tesla's vehicle AI program. The same broader perception, planning, training, and inference expertise can potentially contribute to the robot's ability to interpret its surroundings. But seeing a room is not the same as understanding a room. Gen 3 might detect a small object on the floor, but it has to determine whether that object is a toy, a pillow, clothing, a fragile item, or an obstacle. The correct response depends on the context. A child's toy might need to be picked up, a glass object might need to be avoided, a sleeping dog should not be treated like an inanimate object. The robot therefore needs to connect visual recognition with spatial reasoning and task objectives. The difficulty increases when the environment changes. Imagine Gen 3 carrying a glass from the kitchen toward a table when a child suddenly runs across its path. The original trajectory is no longer safe. The robot must detect the child, understand that the person's position is changing, calculate a safer trajectory, maintain its balance while changing direction, protect the glass in its hand, and then continue toward the destination. Tesla's autonomy research already focuses on planning and decision-making in complicated real-world situations under uncertainty, which is precisely the type of problem a humanoid robot faces when it leaves a controlled factory environment. This is why the real objective for Gen 3 is much bigger than simply giving it better cameras. The robot needs a continuous loop of perception, spatial representation, prediction, planning, and physical action. It needs to transform what its sensors see into an understanding of the environment. Use that understanding to choose a trajectory, execute the movement, observe what changed, and then update its decision. How fast can it actually work inside a home? The real test for Optimus Gen 3 is not whether it can walk, but how quickly it can complete ordinary household tasks without constant human supervision. Tesla is moving toward a robot that can operate continuously in an environment where every task changes from one moment to the next, carrying objects, cleaning, organizing, moving through rooms, responding to people, and adapting when something unexpected happens. One important advantage is the improvement in reaction and movement control. Gen 3 is being developed to move more naturally, maintain balance more effectively, and react to changes in its surroundings. That becomes critical when the robot is carrying something while navigating a home. If a person suddenly steps into its path, Gen 3 needs to slow down or change direction immediately rather than stopping the entire task. The source material specifically identifies faster reactions, improved balance, locomotion, and adaptation to unexpected environmental changes as important areas of development. The more interesting question is what Gen 3 could actually do with that capability. In a kitchen, for example, the robot could potentially move between the refrigerator, counter, sink, and dining area while carrying out a sequence of tasks rather than performing one isolated movement. In a living room, it could navigate around furniture, identify objects left on the floor, move items to appropriate locations, and continue working even as people move around it. The key is that the robot has to coordinate perception, movement, and decision-making continuously instead of treating each action as a completely separate command. Tesla's training approach makes this even more significant. Optimus can reportedly be trained for up to 16 hours per day using demonstrations, video, simulation, and repeated physical practice. That means Tesla can train the robot on specific household behaviors and progressively improve how efficiently it performs them. A task that initially requires slow, cautious movements could become faster and smoother after thousands of repetitions. And this is where time becomes an important metric. A household robot does not need to perform one impressive demonstration for 10 seconds. It needs to work for hours, repeat tasks dozens of times, recover from mistakes, and continue operating without someone constantly resetting it. The source describes Optimus as targeting roughly 8 to 16 hours of operation depending on workload and battery configuration, giving Tesla a much more practical objective than simply demonstrating that the robot can move. Imagine a robot that spends the morning organizing a room, moves objects between locations, assists with household preparation, responds when someone calls it, and then returns to its charging station when its energy is low. The breakthrough is not any individual task. It is the ability to chain many tasks together while continuously adapting to the environment. That is ultimately what Gen 3 needs to prove. Speed is not just how fast Optimus moves its legs. It is how quickly the entire system can perceive a situation, decide what to do, execute the action, recover from unexpected events, and move on to the next task. If Tesla can make that cycle reliable, Gen 3 could become the first Optimus generation that feels less like a machine performing demonstrations and more like a worker capable of completing an entire shift inside the human environment.